Hello friends, next topic is decidable properties of finite automata. What are the decidable properties? What do you mean by the decidable? Those problem for which a general solution is exist is known as decidable, So what are the decidable properties in finite automata? Decidable properties of finite automata. There are 5 properties that are decidable in finite automata. First is emptiness problem. It is decidable in finite automata. Second is finiteness. Third one is membership problem. Fourth is equivalence problem. Fifth is subset problem. Please note this. We will see one by one. See, first, emptiness problem. Is L empty or not? Checking whether the given language is empty or not. Checking whether the given language is empty or not. No. For this, there exists a generalized algorithm. What is the algorithm? The step one is for the algorithm is select those states. Please listen carefully. Select those states which are not reachable from the initial state. Delete those states and transitions defined between them. If the remaining machine contain at least one final state, then we can say machine accept non-empty language, otherwise empty language. Clear? Algorithm. Step first. Select all the state that cannot be reachable from the initial state remove them. Remove them. Clear? This is the first step. Second step. If the resulting machine contain at least one final state, then the finite automata accepts non-empty language. Clear? Next. If the resulting machine is free from final state, then the finite automata accepts empty language. This is the algorithm for emptiness problem. Please see. Noted this. We will see some examples on the emptiness problem. Have you done this? See the example. Check whether the given finite automata accept the empty language or non-empty language. Check whether the given finite automata accepts empty language or not. Question first. Second question. Check. See the first question. What is the first step? Select those states which are not reachable from the initial state. Select those states which are not reachable from the initial state. So in the first example, Q2 is not reachable from the initial state. Delete those states and transitions defined between them. If the resulting finite automata contain at least one final state, then we can say finite automata accept non-empty language, otherwise empty language. There is no final state, it means it accept empty language. Empty language. Clear? Do next question. Select those states which are not reachable from the initial state. Remove those states. Which one is unreachable? Q2 is unreachable. Delete this state. If the resulting finite automata contain at least one final state, then we can say it accept non-empty language. It means this accept non-empty language. Clear? Clear? Next property. Second property, finiteness. Second, finiteness. Is L finite? What is the statement? Check given finite automata accept finite or infinite language. Clear? For this, there is a generalized algorithm. What is the algorithm? Please listen carefully. First step, select those states which are not reachable from the initial state. Delete those states and transitions defined between them. Second step, select those states from which we cannot reach the final state, means dead state. Select those states from which we cannot reach the final state, it means dead state. Delete those states. If the resulting machine contain at least one final state and there is no cycle and no loop, it means finite automata accept finite language, otherwise infinite language. Clear? See the algorithm. Step 1. Select all states that cannot be reached from initial state delete those state, delete those states. Step second, select those states from which we cannot be reached final state. It means dead or trap state, dead state. Cannot be reached final state. Remove those state. Remove those state. Clear? Now, next point. If the resulting machine contain at least one final state and no cycle or loop, then finite automata accepts finite language. Clear? Next point. If the resulting machine contain at least one final state and cycle or loop, then finite automata accepts infinite language. Clear? Please noted this algorithm. After that, we will see some examples. Clear? See some example. Example 1. Check given finite automata accepts finite or infinite language. Finite or infinite language. What is the finite automata? Q naught Q1 Q3 Q2 01 Q4 01. Check whether the given finite automata accept finite language or infinite language. Yes. Check. What is the first step? Select those states which are not reachable from the initial state. There are any state which are not reachable from the initial state? Yes. This one, Q4. Delete those state and corresponding transitions define between them. There is also a transition from. Now, second step. Select those states from which we cannot reach the final state. With the help by the Q3, we cannot reach the final state. It means this is the dead state. Dead state. Delete that state and corresponding transitions. Delete this one. If the resulting machine contain at least one final state, yes, resulting machine contain at least one final state. There is any cycle or loop? Yes, this one is cycle. It means it accept infinite language. Clear, my dear friends? Do next question. Do next question. Check whether the given finite automata accept finite or infinite language. Check. whether the given finite automata accepts finite or infinite language. What is the finite automata? Q1, Q2, Q3, Q4 on 0, 0, 1, 1, 0, 1, 0, 0. Please check this. Do fast. Yes, check. There is any unreachable state? All are reachable states. All are reachable states. All are reachable from the initial. Q1 is reachable, Q2 is reachable, Q3 is reachable, Q4 is reachable. There are any dead states? Yes, these are the dead states. These two states are dead. Why these are dead state? Because we cannot reach the final state from Q3 and Q4. Delete those states and corresponding transitions. If the resulting machine contain at least one final state, yes, it contain one final state. There is any cycle or loop? No, there is no cycle, no loop. That's why no cycle, no loop. That's why it accepts finite language. Clear? Finite language. Clear? Now do. Next. Membership. Next property is membership property. What do you mean by the membership? Given string is accepted by the finite automata or not? Given string is accepted by the finite automata or not? Membership is W belongs to L or not? What is the statement? Checking whether the given language is finite or not. Sorry. Checking whether the given string is a member of language or not. What is the algorithm? Run the string w on DFA where DFA accepts the given regular language L if W is a member of L, then it will reach final state, otherwise it reaches non-final state. We'll see one example. Note it fast. Okay, see one example. Suppose this is the finite automata. The length of the string is at least 2. AB check this string is a member of this finite automata or not. Read A. Check this string A is a member of this finite automata or not. When we read a input symbol A on Q0, it goes to Q1. This is non-final state. It ends here, non-final state. That's why A not belongs to the language that is accepted by the given finite automata. Clear? Okay, move to next property, equivalence property. Fourth, equivalence. What do you mean by this? Is L1 equivalent to L2? What is the statement? Checking checking whether the given string checking whether the given two regular language are equal or not. No. Okay. What is the algorithm? Construct the two DFA, one for L1, one for L2, and minimize these two DFA. If both are equivalent, it means both accept the same language. Both languages are equivalent. Construct D1 and D2 to accept D1 and D2 are DFAs. Accept the language L1 and L2 respectively. Construct a new finite automata by combining D1 and D2 as follows. Please. First point. Create a new initial state as Q0 and QA by combining both initial states of D1 and D2 where Q0 is an initial state of D1 and QA is an initial state of D2. Clear? Please see. Second point. Cover the transition cover the transition from the initial state for all input symbols using D1 and D2. Clear? This is the second point for this algorithm. Okay? Now see the next point. If any new state found while covering the transitions then cover all the transitions for the new state repeat step 3 until there is no new state created. There is no new state created. Next one. If there exists a pair, this point is very important. If there exists a pair P comma Q as I state in the combined finite automata and one of its state is final and other is non-final, and other is non-final, then the given two language accepted by those D1 and D2 are not equal, Clear? Next, if there exists no distinguishable pair what do you mean by the distinguishable? Means every pair is final or non-final. This pair is non-distinguishable. Clear? If there exists no distinguishable pair in the combined finite automata, then those given two languages are equal. Clear? We'll see example. Please note this complete algorithm. Okay, question. See the example. Check whether following two finite automata accepts same language or not. What are the finite automata? Please check. Q1, Q2, Q3, C, D, C, D. Next is Q4, C, Q5, D, Q7, Q6, C. Check given these two finite automata accept the same language or not. One method is this: minimize these two NF finite automata. If they are same, it means they accept the same language. Otherwise, use the comparison method. Okay. See the comparison method. C, D, Q1, Q4. Q1 on C, Q1, Q4 on C, Q4, both are final. Q1 on D, Q2, Q4 on D, Q5, non-final. Okay, which one is new pair? Q2, Q5, Q2 on C, Q3, Q5 on C, Q6, both are non-final. Both are non-final. Q2 on D, Q1. Q5 on D, Q4. Both are final. Both are final. There is any new pair? Yes. Q3, Q6. Q3, Q6. Q3 on C, Q2. Q6 on C, Q7. Both are non-final. Q3 on D, Q3. Q6 on D. Sorry. What about the D? Wait, I'll check. D. This is D. Q6 on D, Q6. Non-final. All are non-final. Now, there is any new pair? Q1, Q4, Q2, Q5, Q3, Q6, Q2, Q7. This one is new pair. Q2, Q7. Q2 on C, Q3. Q7 on C, Q6. Q2 on D, Q1. Q7 on D, Q4. This pair is non-final, this pair is final. There is any new pair? No, no. Stop here. There is no distinguishable pair. That's why it accepts the same language. Same language. Same language. Both are equivalent. Both DFAs are equivalent. Both DFAs are equivalent. Clear? Clear? Now check next example. C. C. Check these two are equivalent or not. C. C, D. Q1, Q4. Q1 on C, Q1. Q4 on C, Q4. Both are final, 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 final. Q1 on D, Q2. Q4 on D, Q5. Non-final, non-final. Next pair, Q2, Q5. Q2 on C, Q3. Q5 on C, Q7. Non-final, non-final. Q2 on D, Q1. Q5 on D, I think there is a mistake in transition. This one is D. This one is D. This one is D. Q2 on D, Q1, Q5 on D, Q6. This is final, this is not final. Stop here. This is this is distinguishable pair. Stop here. And result is both DFA are not equivalent. Both DFA are not equivalent. Why? Because it goes to final state and it goes to non-final states. Clear? Clear? See the next and last property. Subset problem. Next and last property, subset problem. Fifth, subset. What do you mean by this? Is L1 is a subset of L2. How to prove this? Take the DFA that accept L1 and L2. After that, take the complement of DFA that accept the L2 and intersect L1 and L2. If they return empty language, then we can say L1 is a subset of L2, otherwise not. Please listen carefully. L1 take complement of L2 if intersection equal to 5. Then we can say L1 is a subset of L2, otherwise not. Otherwise not. Please listen carefully. Checking whether the given regular language L1 is a subset of given regular language L2 or not. What is the solution or what is the algorithm? Construct D1 and D2 to accept L1 and L2 respectively. If D1 intersect complement of D2 is accept an empty language, then L1 is a subset of L2, otherwise L1 is not a subset of L2. Clear? These are the decidable properties of the finite automata. There are 5 properties that are decidable. First one, emptiness. Second one, finiteness, membership, equivalence, and subset problem. In GATE examination, one marks question asked based on these properties. Which of the following is the decidable properties of the finite automata? Yeah, which of the following is not decidable properties of the finite automata? Clear? In next lecture we will see regular expressions.